Alright, welcome. It's Miss Skelton here, and I'm sorry I can't be with you today, but you're still going to be able to go through and do some exploration, and then I'm going to come back in the video and summarize your findings, and we will go over this more next class. So, write any questions down. I promise I'll get them answered. The first thing you're going to do is go to Canvas, and I put a link to Desmos. It gives you a function and a crazy looking equation that makes a half circle on the graph. And then there are a bunch of lines underneath that all make a change to the equation. So some of those changes are in parentheses with the x, some of the changes are at the end of the equation. What I want you to do is, for each equation, I want you to click the circle next to that equation, and it will graph that new function, and you're going to make a note of how it changes from the original. So it's going to graph a second half circle, and you're going to tell me, did it shift to the left or right, up or down? Did it get flipped? Did it get wider or narrower? And you're just going to make some notes and see if you can find patterns so that when we come back and actually explain what we found, you've kind of seen it visually rather than just having to trust me. Okay, so go ahead, pause the video and take 10 to 15 minutes to work on this exploration. If you don't have your own device, then just share with a neighbor and look on together. Okay, after you've explored, then we're coming back together to see what we found. So, on your notes paper, today's title is Function Transformations, and we're going to focus on three different numbers that could change an equation and then make the graph look differently. So I'm going to write the function in function notation. F of x, you might remember from Algebra 1, is just another way to write y equals. And then for our functions, you saw sometimes there was a front number. Then I'm going to put x minus, whiteout is good. X minus c, and then a plus d at the end. I know I skipped over b. We'll talk about it later in the year, but for right now, a, c, and d. Three places where I could put a number that would change the graph. So you might have noticed that for a, if I put a negative in front of the equation, that graph flipped over the x-axis. So in Algebra 2, you can either call that a reflection over the x-axis or a flip over the x-axis, and this happens when I have a negative a. We also get kind of lazy and abbreviate it ROXA, reflect over x-axis. We're all about saving time, paper, and lead. Okay, two other things can happen here. If that a value, ignoring the negative, is greater than 1, you might have noticed that u, it got stretched. It got narrower and taller, and so we call that a vertical stretch. If that number is between 0 and 1, so your fractions like a half or a third, or maybe it's listed as 0.8, that is a vertical compression. So in a minute, I'm going to do some abbreviating when we actually look at a problem. So here are the three ways that our front number can change the graph. This might feel familiar from Algebra 1. You did this with quadratic U-shaped graphs. Okay, the second thing that we could do is put a number added or subtracted with x in the parentheses. Now, everything with x, I'm hoping you noticed, it might have been shifting the opposite way that you would think. So if you saw x minus c, it actually shifts the graph to the right, even though it has a subtraction sign. And x plus c shifted the graph to the left. And then the last thing that we could do is add or subtract a number at the end. This is another shift. If you see plus a value, that shifts our graph up. Minus a value shifts our graph down. So this one should match what you would assume. Plus is up, minus is down. So the way I'm going to ask you these questions, and what you'll see on your homework, is I'm going to give you different equations. So let's do 3 examples. Okay, the first one I want to do is y equals 1/2 x minus 3 squared plus 1. And we are going to identify the type of function, and then we're going to talk about what each of these numbers does to the equation. So there's always going to be some sort of symbol in the equation that tells you the type. Hopefully you noticed I wrote that this is squared. It helps me know the type of graph. Think about what equation was squared from last class. You learned about it in Algebra 1. This equation is quadratic and would make a U-shaped graph even though we're not going to go look at it. Okay, there are 3 numbers in this equation that made changes to it. Let's talk about what they did. And you can label them like this on your assignment that you'll work on after your quiz. So it looks like I have a front number of 1/2. Okay, that's between 0 and 1. So that is a vertical compression. So you can put V and then abbreviate compression COMP, a vertical compression. Then we're going to move on to x minus 3. We said everything with x is opposite, so this is going to shift the graph x minus 3 to the right. So you can actually abbreviate right 3, R3, or write it out if it makes you happy. And then also from the parent function, this plus 1 at the end is another shift. That plus 1 means it's going to shift the graph up 1 unit, which you can abbreviate U1. Okay, so identify the type, tell me what each number does. So let's do another one. Y equals -3. This symbol, which is giving away our function type, and I'm going to put in x plus 2, and done. Okay, so if you know what symbol this is, you know the type. That's a square root. So this is a square root function. The -3 does 2 things here. So the fact that it's negative, let's talk about that. The negative itself means that I have a reflection over the x-axis. This graph is going to be flipped. Okay, so again, that's what that abbreviation means. And then the 3 itself, because 3 is bigger than 1, again, we've already used the negative, 3 is bigger than 1, so this is a vertical stretch. Okay, the other change I made to the equation is with x. So if it's under the square root, that's going to be shifting left and right. It's with x, and the opposite direction you would think. So plus means we're shifting left too. Okay, y'all, let's do one final equation. Y equals negative. Hopefully you're thinking about what these lines are. I'm going to put an x minus 4 and a minus 2 at the end. Okay, so see this one, the fact that I put it in these absolute value lines should be letting you know that this is absolute value. And then let's go part by part. The front number could stretch, compress, or reflect. I just have a negative. So it looks like I have a reflect over the x-axis. So instead of that V opening up, it would actually be opening down when it gets flipped, because absolute value is our V-shaped graph. Okay, now there's no other number there, so this graph did not get stretched or compressed. It's the same width. With x, it's moving the opposite way I would think, so it's going to move to the right 4. Any value added or subtracted at the end is shifting my graph up or down. Minus means down, so I'm shifting the graph down 2 units. Now this is what to expect on the test. I will give you equations where you're identifying the type and telling me how they shifted or changed from the parent function. I'll answer any questions you have about this next class. This lesson is not on today's quiz, but that's what you're going to be doing next. So if you need to take a few minutes to look over your parent function table, you get to use your notes. So find your notes over parent functions and domain and range, and then try your best on the quiz, and we will review next class.